Now let's move on to LCM and HCF models, a very important and interesting concept, where basically what I have done is categorized LCM questions into 3 types and HCF questions into 2 types. And what I mean by types is these are standard patterns, and if you can identify the standard pattern, you can solve them and write your answer directly instead of bothering and doing the long method. Okay, what are these patterns? Very easy to identify. Let's look at LCM models first. So model 1 is when any number, when it divided by PQR, it can be divided by 2 numbers, 3 numbers or 4 numbers. I have taken 3 for example. It leaves the same remainder in each case. The important part is it leaves the same remainder. Okay. So in that case, the number must be of the form n is equal to LCM of PQR into a constant plus s, where s is the remainder, where s is the common remainder. That is what it means. For example, let's take an example and understand. When a number divides, let's say 2, 3 and 5. So the number is divided by 2, 3 and 5. So this is the divisor. My remainder is 1 in each case. Okay. I have to find the dividend. So my dividend is nothing but, or my answer is nothing but LCM of 2, 3, 5 into k. K because you will not get one answer, you will get multiple answers, plus 1. 2, 3, 5, all of them are prime, so their LCM is the product 30. So answer is 30k plus 1. This is the answer. Okay, and k is a natural number, so k in fact can be 0 also, but 0 normally is not taken because then nothing gets divided. The quotient will be 0. So if I take k as 1, then your first number is 31. So let's check 31. 31 divided by 2 will give you remainder of 1. 31 divided by 3 will give you remainder of 1. 31 divided by 5 will give you remainder of 1. If you take k as 0, 1 divided by 2 will also give you 1, but in that case the quotient will be 0. K if you take as 2, then you will have 61. 61 will also satisfy this. So you will not get one answer, you will get multiple answers. Fine. So this is your LCM model 1. What you have to remember in model 1, your remainder is same. Your remainder is same. If a number is getting divided by multiple divisors and the remainder is same, that means it is LCM model 1. Okay. Second model, LCM model 2. Exactly same as the first question, except that in case the remainder is not same, but the difference of your divisor and remainder is same. For example, let's say my divisors are 4, 5 and 6. My remainders are 2, 3 and 4. And there's a divisor there's a dividend which I do not know. Now if you see that my remainders are not same, but divisor minus remainder is how much? 4 minus 2 is 2, 5 minus 3 is 2, 6 minus 4 is 2. So there the difference is constant. This is your LCM model 2. And in this case the answer is again LCM of PQR into constant, same part, but minus that common difference. Minus that common difference. So here my answer should be LCM of 4, 5, 6 k minus 2. Okay, 4, 5, 6, 4 and 6, their LCM is 12, 12 and 5 it is 60, so 60k minus 2. Okay, if I take k as 1, and here you can see k minimum is 1, you can't take k 0, otherwise your number will be minus 2. Okay, so if you take k as 1, 60 minus 2, 58. So your first possible answer is 58. Now 58 if I divide by 4, you will get a remainder of 2. 58 if you divide by 5, you will get a remainder of 3. And 58 if you divide by 6, you will get a remainder of 4. You can take k as 2 also, in which case you will get 120 minus 2, you will get 118. 118 also will have the same property. So you will get multiple answers. But simple model, all that you have to remember is that your divisor minus remainder is a constant. Okay, and then you have the third model, most important model, where there is nothing common. The remainder is not same, divisor minus remainder is also not same. So this is more of a universal model which applies in all cases. And this you will not understand what is written here. Let's take an example and then I will explain this to you. Okay. So let's say that we have, let me erase what I've written here so that I can explain to you. Okay. Let's say that I have a certain dividend which, when divided by 5 and 6, gives me remainders of 2 and 5. Let's say these are my divisors, these are my remainders. Now you can see that your remainder is not same, divisor minus remainder is also not same, so there is no particular pattern. Okay, I have to find the dividend. Now here no formula will work. Here we work from basic concepts, first principles. Okay, I have to find the dividend here. So let's understand what will be my dividend. Divisor is 5. I hope you remember we had discussed some time back, dividend is equal to divisor into quotient plus remainder. I know the divisor also, I know the remainder also, I don't know the quotient. So I can assume the quotient to be x. So I can say that my dividend is 5x plus 2 in the first case. And obviously the dividend is same in the second case also. So my dividend is 5x plus 2. Now this 5x plus 2, when it divides, it is divided by 6, it leaves me a remainder of 5. I hope you remember that I told you dividend minus remainder will be fully divisible. So now that my remainder is 5, if I subtract this 5 from the dividend, which is 5x plus 2 minus remainder, this should be fully divisible by 6. 6 into y, let's say the quotient is y. Fine, I hope you're okay with me till here. This is one method of looking at it. The second method is my dividend from the first case I can say is 5x plus 2 and my dividend from the second case is 6y plus 5 because 6 is the divisor, 5 is the remainder, and both the dividends have to be same. So 5x plus 2 is equal to 6y plus 5. That will also give you the same equation. Okay, so basically you get 5x plus 2 minus 5, which is 5x minus 3 is equal to 6y. Okay, now once you get this equation, by hit and trial you have to find the value of x and y, the smallest possible pair of values which satisfy this, given that x and y are integers. So if I take x as 1, you get 5 minus 3, which is 2, which is 6y, not possible. If you take x as 2, you get 10 minus 3, 7, not possible. If you take x as 3, 15 minus 3 is 12, 12 is 6y, yes, y is 2. So x at 3 and y 2, this satisfies. This is the smallest possible value. Now you can put x as 3 in this one, or you can put y as 2 in this one. Both of them will give you same answer. So if you put x as 3, 5 into 3, 15 plus 2, 17. If you put y as 2, 6 into 2, 12 plus 5, 17, you get the same answer. So 17 now becomes your smallest possible value which satisfies this case. 17 divided by 5, you can see that you get a remainder of 2. And 17 divided by 6, you can see that you get a remainder of 5. Okay. Now your answer is going to be LCM of 5 and 6 into k. See, this part always remains same. You always will have LCM of the divisors into the constant. That part will always be there in LCM model 1, LCM model 2, LCM model 3. The only thing is after that we have to add or subtract something. Model 1 was very simple, you add the common remainder. Model 2 is also very simple, you subtract the common difference. Model 3 was a problem because there was nothing common. So for model 3, you add what we found just now, this 17. So this 17 is added. Okay, so 5 and 6 LCM is 30. So your answer is 30k plus 17. Okay, and k again here is a whole number. K can be 0. If k is 0, 17 is your answer, which we checked. If k is 1, you'll get 47. And 47 also, if you divide by 5, you'll get a remainder of 2. 47 if you divide by 6, you'll get a remainder of 5. Okay, so k can be again anything. Okay, so coming back to this, any number n when divided by p and q leaves remainders of r and s. So the answer is of the form LCM PQ into constant plus n, where n is the smallest integer solution of n is equal to p m1 plus r and n is equal to q m2 plus s, where m1 and m2 are natural numbers. So basically instead of m1 and m2 we have taken x and y. Okay, so don't go by theory so much. I hope you have understood here. We'll do some questions so that we are absolutely clear with this. And questions, when they come in exam, questions will not be in this form. Question will be some application of this concept. And when you see the application of the concept, you'll have to understand that, oh, the concept, the core underlying concept is LCM model 1 or 2 or 3, and solve accordingly. For example, if you see this question, if a class teacher distributes 4, 9 and 12 chocolates to each student of the school, they are left with some spelling mistake here, ignore that. They're left with 2 chocolates in each case. That means if they distribute 4 chocolates, then they're left with 2. If they distribute 9 chocolates, then also they're left with 2. If they distribute 12 chocolates, then also they're left with 2. Okay, so obviously they are distributing so many chocolates. These are the divisors, these are the remainders. What is the number of students in the school if it is the smallest 4-digit number? So dividend is what we have to find out. Okay, so clearly you can see that because your remainder is constant, it is LCM model 1. So your answer is going to be LCM of 4, 9 and 12 into constant plus 2. Now 4, 9 and 12, let's check 12 multiples of 12. 12 is already a multiple of 4, so you don't have to bother about 4. 12, then 24, then 36. So 36k plus 2. Okay, this is your answer. And the question says it is the smallest 4-digit number. So if I take k as 30, it will become 36 into 30, which is 1080 plus 2. That's a bit too much. I need to subtract about 80, so k should be taken as 27. Okay, if I take k as 27, that means now I'll get 36 into 27 plus 2, which is 32, 4 carry, 21, 4, 25, 25, 35, 36, 37, 3 carry, you have 6, 972 plus 2, 974. Okay, 974 is your largest 3-digit number, but the question was smallest 4-digit number. Okay, so k should not be taken 27, but k should be taken as 28. Okay, or because I have this already, in fact for every increase in k, the value is going to increase by 36, right? So I can just add 36 to this. So my answer is going to be 1010. So 1010 would be your answer, which is the smallest 4-digit number, which you will get at k is equal to 28. Okay, so that is going to be the answer for this question. Fine. This is LCM model 1, and how you identify this model? 2 chocolates are left in each case. Okay, let's look at model 2. Milk from a tanker is poured into smaller containers. When the containers are of 2, 3, 4, 5 and 6 liters, then 1, 2, 3, 4 and 5 liters of milk remains respectively. How many sizes of containers are possible if it is less than 200 liters? Okay, clearly my divisors are 2, 3, 4, 5, 6. My remainders are 1, 2, 3, 4, 5. Divisor minus remainder is 1, 1, 1, 1, 1. This is common, so I should be able to get my dividend. Okay. How many sizes of containers are possible if it is less than 200? So you know the method. It is LCM of 2, 3, 4, 5, 6 into a constant minus the common difference. Okay, 2, 3, 4, 5, 6. The LCM is, we had done this some time back. The LCM would be 60. 6 ka multiple, you can see that 60 would be the smallest number which will satisfy this. 30, yes. So it is basically 60k minus 1. After some practice, in fact, LCM you will get directly. You won't even have to calculate. Okay, so 60k minus 1. How many sizes of container are possible if it is less than 200? So if I put k is equal to 1, remember you can't put k is equal to 0, you will get 59. If you put k as 2, you will get 119. If you put k as 3, you will get 179. If you put k as 4, you will get 239, which is not possible. So the container could have been of any of these three sizes. Hence the answer is fourth choice. Okay, so very simple. How did you identify model 2? Your divisor minus remainder was same. Okay, let's look at model 3. The teller at a bank is making stacks of 1 rupee coins. So here certain 1 rupee coins, he's making stacks of them. When he makes stacks of 5, 7 and 8 coins, 2, 1 and 4 coins are left out respectively. Okay, so now the divisor is 5, 7, 8. The remainder is 2, 1, 4. You can see remainders are not same, and divisor minus remainder also do not follow a pattern. It is 3, 6 and 4 in all three cases, so there is no pattern. So now this will have to do from the core concept. The core concept again would be slightly different here because we had done for 2 numbers, here you have 3 numbers. So we'll have to do twice of what we did earlier. So understand this and see this very carefully. From the first case, my dividend would be 5x plus 2. Okay. From the second case, my dividend will be 7y plus 1. Equating both of them, 5x plus 2 is equal to 7y plus 1 gives me 5x plus 1 is equal to 7y. Okay. Now let's check for values of x and y. X is 1 gives me 6 is equal to 7y, not possible. X is 2 gives me 11 is equal to 7y, not possible. X is 3 gives me 16 is 7y, not possible. X is 4 gives me 21 is 7y, which is possible. 21 is a multiple of 7. So it gets satisfied at x is equal to 4 and y is equal to 3. Now this I can put in either of the equations. 5x plus 2, if you put x is 4, you will get 22. 7y plus 1, if you put y is equal to 3, you will still get 22. Okay, so 22 is my smallest possible number. The answer for first and second case is LCM of 5 and 7k plus 22, which is 35k plus 22. Okay, so that is the common answer. Okay, so let's now see the step, because now this is a slightly different step. You have not got the answer yet, but 35k plus 22 is my answer for first and second. And what is the answer for third? Third answer is 8z plus 4. Right? So let's equate this to 8z plus 4. Okay, so we do that once again. So that gives me 35k plus 18 is equal to 8z. Okay, remember here k can be 0 also. So starting with k is equal to 0, we try and find integral solution of k and z. So if k is 0, 18 is equal to 8z, which is not possible. If k is 1, we will get 35 plus 18, that is 53 is equal to 8z, not possible. If k is equal to 2, you get 70 plus 18, 88 is equal to 8z, which is possible. It will be 8 into 11. So at k is equal to 2, you get z is equal to 11. Okay. Again, we can put k as 2 or z as 11. Same thing. If you put k as 2, you will get 35 into 2, 70. 70 plus 22, 92. If you put z as 11, you will get 8 into 11, 88 plus 4, 92. Now 92 becomes the smallest number which satisfies all three cases. Earlier we had got 22, right? But 22 was a number which satisfied first and second. Now 92 is the number which satisfies all three cases, and let's check that. 92 divided by 5 gives you a remainder of 2, yes. 92 divided by 7 gives you 1, yes. 92 divided by 8 gives you 4, yes. So the smallest possible number is 92. Now the answer is going to be LCM of 5, 7, 8, K. This part, remember, is always same for LCM model 1 or 2 or 3. The only part that we did this was to get this 92. So the answer is LCM of 578K plus 92. 578 have nothing in common. So it will be product. 8 into 5 is 40. 40 into 7 is 280. So 280K plus 92 is your answer. The question is asking you largest 3-digit number. So you can see that if I put K is equal to 3, I'll get what? 200 is 600 plus 240, 840. 840 plus 92, which is 932. So 932 is going to be your answer for this question. Okay, so answer is 932, which you get for a value of K equal to 3. Okay, so what would happen if there was a fourth divisor also? I hope you have understood that. So 280K plus 92, then you would have matched that with the fourth one, and then you would have found the value of K once again. Okay, so it can go on like this, but this is very important to understand because we are doing this from the core concept. Okay, good. So now let's move to HCF models. There are two models in HCF. And HCF, remember, you are given the dividend, you have to find the divisor. Okay, so you have to find the smaller number. So first model is a number divides P, Q and R and gives remainders of S, T and U respectively. Okay, as simple as that. There is no pattern, nothing. You know all the divisors, you know all the remainders. That's all. You know all the divisors, you know all the remainders. Okay, then the HCF, the largest such number is the HCF of divisor minus the remainder. This comes from the basic concept that you know that dividend is equal to divisor into quotient plus remainder. Okay, so if a given number divides P, Q and R, so if I know the dividend, if I know the remainder, and if I do D minus R, that will always be fully divisible. So I have this number. Similarly, I get three such numbers. So let's say this is D1, D is same. I have D1, Q1 plus R1. I have D2 is equal to D2, Q2 plus R2. Sorry, it's not D2, it is D. And no, sorry, this is D1, this is D2, divisor is same, so this is D. And then you have D3 is equal to D into Q3 plus R3. Okay, so you have D1 minus R1 is DQ1, D2 minus R2 is DQ2, and D3 minus R3 is DQ3. So you basically find HCF of these values. As simple as that. For example, let's take an example. So I have, let's say 21, 42 and 63. These are my dividends and my remainders are 1, 2 and 3. Okay, and I want to find the divisor. So basically we are saying subtract the dividend and the remainder. You get 20, you get 40, you get 60 and you take their HCF, which is 20 in this case. So 20. So 20, now you can see if 21 is divided by 20, you get remainder of 1. If 42 is divided by 20, you get remainder of 2. If 63 is divided by 20, you get remainder of 3. So no pattern required. You know all the three dividends and you know all the three remainders. Straight away, you do dividend minus remainder, and that value you take their HCF and you get the answer. One word of caution here, that remember that 60 is not the only, 20 is not the only answer. There can be factors of 20 also. So other numbers can be factors of 20. So factors of 20, what are factors of 20? 1, 2, 4, 5, 10 and 20. All of these are possible answers, but there is one condition. When you make this equation, your remainder always has to be smaller than the divisor. Your divisor always will be greater than the remainder. Okay, remember that. So you can see that your remainders are 1, 2 and 3. The largest remainder is 3. Your divisor or your HCF has to be greater than 3. So 1 and 2 are not possible. 4, 5, 10, 20, all these are correct. And you can check. 21 divided by 4 will also give you 1. 42 divided by 4 will give you 2. 63 divided by 4 will give you 3. 21 divided by 5 will give you 1. 42 divided by 5 will give you 2. 63 divided by 5 will give you 3. So you divide by 4, 5, 10 or 20. In each case, it will get satisfied. So all these are possible answers, but the largest possible answer is the HCF. Okay, so this is your model 1. Let's look at model 2. Model 2 is a number divides PQR such that the remainders are same. So model 2 is when the remainders are same, but you do not know that remainder. Okay, so let's take this 21, 41 and let's say 81. Let's say these are my dividends. The remainder is same, R, but I do not know them. Okay, now what do I do? This is very interesting here. So let's make equations. First equation, my D1 divisor anyway is same, and it is given that remainder also is same. D2 is dQ2 plus R and D3 is dQ3 plus R. Okay, now if I do D1 minus D2, what do I get? R gets cancelled. You get D into Q1 minus Q2. If you do D2 minus D3, you get D into Q2 minus Q3. If you do D3 minus D1, you get D into Q3 minus Q1. Right? All these you can see, all these are fully divisible. There is no R there. So basically, you do nothing but you take HCF of all of them. You take HCF of them and that gives you the answer. Okay. If you understand that here, 41 minus 21 is 20. 81 minus 41 is 40. 81 minus 21 is 60. So basically, you take HCF of 20, 40 and 60, which is 20. So your answer is 20. And you can see if 21 is divided by 20, you get a remainder of 1. If 41 is divided by 20, you get a remainder of 1. If 81 is divided by 20, you again get a remainder of 1. Okay. So basically you subtract. One more interesting thing here is that actually you need to cover each dividend once. So you don't have to take all three of them. Here you can see each dividend is coming twice. If you take any two of them, that's also good enough. This you can leave. Leave this. You will reduce one step. Your D1 has come. Your D2 has come twice, no problem. D3 has also come. They don't have to come twice. They have to come at least once. And you can check here, 20 and 40. If you take, the HCF is 20. 60 and 40 if you take, the LCM is still 20. 20 and 60 if you take, the LCM is still 20. So you take any two of them, that's good enough. You don't have to take all three of them, 20. Okay, again one word of caution here, 20 is the highest common factor. Factors of 20, 1, 2, 4, 5, 10, 20 are also possible. Not 1 because the remainder is 1, but all these are correct answers. 2, 4, 5, 10, 20. 20 is the largest possible answer. Okay, great. Let's do a couple of questions to understand them better. First question, and again these will be practical questions. These will be applied questions, not theoretical. So there are so many students who are going on an excursion separately in buses of same seating capacity. So 387 students go in some buses, 705 go in some buses, 1235 students go in some buses. What can be the maximum seating capacity of the buses if 2, 5 and 10 students are left out after filling all the buses? Okay. So when 387 go, 2 are left out. That means 385 can go fully. Similarly, if 705 go, 5 are left out. That means 700 can go fully. And if 1235 go, then 10 are left out. That means 1225 can go fully. So it is basically a dividend minus remainder. So it is LCM model 1, so HCF model 1. So you do nothing but find HCF of these values, right? 385, 700 and 1225. Okay, so let us look at what are the common factors here. We can see that 5 is common. So let's take out 5 first. If I take out 5, 385 will become 77. 700 will become 140 and 1225 will become 245. Okay, fine. Then I do not have 3 common, I do not have 5 common, but I have 7 common. If I take out 7, then this will become 11, this will become 20, and this will become 35. Now there is nothing common between them, so the HCF is 35. Okay, so the HCF is 35. That means the capacity of each bus should be 35. And you can check here, 387 divided by 35 will give you remainder of 2. In fact, now we can write it like this. 387 is equal to 35 into whatever is here. Okay, into 11. Okay, plus the remainder that is given to you here. Okay, similarly, 705 is equal to 35 into, we have 20 here, plus remainder of 5. And 1235 is equal to 35 into 35 plus 10. So these are who are left out. This is the capacity of the bus and this is the number of buses which are required. So what can be the maximum seating capacity of the bus? The answer is 35. The maximum seating capacity can be 35. How many buses are being used? Is 11 plus 20 plus 35. So that is 5, 6, 3, 4, 5, 6. You are going to use 66 buses. So answer for the second part is 66. Okay. So this is your HCF model 1. Then let's look at HCF model 2. A ration shop has 130 kg of rice, 790 kg of wheat, 1270 kgs of pulses which are being distributed among a certain number of people, and equal amounts of rice, wheat and pulses remain undistributed. Equal number, that tells you it is HCF model 2. Okay, so my dividends are 130, 790 and 1270. I hope you remember we said just subtract D2 minus D1 and D3 minus D2. You don't have to do all three. Okay, so this 790 minus 130 is going to give you 660 and this is 1270. So this is 270 plus 210 is 480. So you have HCF of 660 and 480. Okay, so first thing you can see that there is a 10 common. Let's take that out 10. So you have 66 and you have 48. Then we have a 2 common. Let's take out 2. We have 33 and you have 24. There is a 3 common. Then you have 11 and you have 8. Now nothing is common. So 10 into 20, 20 into 3, 60. So there can be 60 people. 60 is the highest number of persons who can be there. Okay. So to answer the first question, what are the possible number of people? 60 is 1. But remember, it can be factors of 60 also, which we'll look at in a bit. Now, if there are 60 people, so 130, 790 and 1270 is being distributed among 60 people and 60 people. So 130 divided by 60, that means 10 will be the remainder here. 10 will be the remainder here, 10 will be the remainder here. So this is my remainder, this is my divisor, and this is my dividend. Okay, so first answer, what are possible number of people? 60. Now because your remainder is 10, can I have factors of 60 also? Which should be greater than 10. Okay, so 60 greater than 10, you basically have 12, 15, 20, 30 and 60. So in fact all these 5 are possible. 12, 15, 20, 30, 60, any of them can be the divisor. So question is, what are possible number of people? It is 60, 30, 20, 15, 12. All these 5 are possible. If the question was what is the maximum possible number of people, answer is 60. Each person gets how many kg of rice, wheat and pulse? Again, this will depend on how many people are there. If there are 60 people, you can see 130 divided by 60. So basically now the question is finding out the quotient. So every person gets 2 kgs of rice. 790 upon 60 will be 13. Each person gets 13 kgs of wheat. And 1270 upon 60, you will have 21. Each person gets 21 kgs of pulses. So 2, 13 and 21 if number of people is 60. If number of people is 30, value will become twice. If it is 20, it will become 3 times. If it is 15, it will become 4 times. If it is 12, it will become 5 times. Okay. How many kgs of rice, wheat and pulses remained undistributed? This answer is 10 kgs each. 10 kgs each. So this is the answer for this question. Okay. So I hope you have understood both the models. So this is basically all about LCM and HCF. We have done all possible combinations and a lot of questions so that we are familiar with every type of question that you can have on this. Okay. One last concept that we'll touch upon is successive division, not related to LCM or HCF, but because it looks very similar, it makes sense to do it together. Okay. And since we are anyway discussing about divisor, dividend, quotient, remainder, it falls in the same line. Okay. So what I mean by successive division is, let's say I have a number 105. Okay. This 105 I divide by, let's say, 20. Okay. So I divide this by 20. This will get divided 5 times 100. I'll get let's not take 20. Let's take a smaller divisor. Let's say I'm dividing it by 4. Okay. So if you divide it by 4, you can divide it 26 times. You'll get 104, you'll get 1 as the remainder. So your quotient is 26. Okay. Now this quotient, 26, becomes your dividend for the next division, and I say it is now divided by 3. Okay. So when you divide it by 3, you will divide it 8 times, 24, your remainder is 2. This quotient now becomes your dividend for the next division. So 8. And I'm now dividing, let's say, by 5. You will have it 1 times 5 and you will have a remainder of 3. Okay, so basically quotient of the previous division becoming dividend of the next division is what is called as successive division. Okay, so if quotient of the dividend is taken and then it is used as the dividend in the next division, such a division is called successive division. And a successive division can continue up to any number of steps until the quotient in the division becomes 0 for the first time. So in fact, I have 1. I can still divide it one more time and I can say, okay, now this 1 is divided by 2. It will get divided 0 times and basically now 1 will be the remainder. So quotient now becomes 0. So basically I have done division 4 times, and if I write this now, my dividend and remainder. So my dividend in the first case was 105. My remainder was 1. My dividend in the second case was quotient of the, let's write the quotient also. So the quotient was 26. Now this quotient becomes my dividend in the second case, where my remainder was 2 and my quotient was 8. This quotient becomes my dividend in the third case, where my remainder was 3, my quotient was 1. This quotient becomes my dividend in the fourth case, where my remainder was 1 and my quotient was 0. So quotient 0, that is where we put this to stop. So you can see quotient becoming dividend in the next step. This is what is called as successive division. Fine. Okay, let's do one question on this and you will be very clear. There is nothing very complicated, just that it looks very similar to an LCM model, but it is entirely different. Okay, so here if we look at a certain number when successively divided by 4, 5 and 7, successively divided by, so these are my divisors, 4, 5 and 7, leave remainders of 2, 3 and 4, find the largest 3-digit number. Okay, so how we do this is we start with the last division, and I do not know that after the last division my quotient has become 0 or not. So I will not assume it to be 0. I will say, let's say the quotient is x. Okay, so we'll assume the quotient to be x. So in that case, my dividend from the last division will be 7x plus 4. Okay, so I'm writing here quotient also, so I'm assuming the quotient to be x. Okay, so my dividend from the last division is 7x plus 4, which for the second last division should have been the quotient. Okay, so if the quotient is 7x plus 4, then the dividend for the second last case will be how much? You have divisor 5 multiplied by quotient 7x plus 4 plus remainder, which is 3. Right, this will become your quotient for the first case. So 5 into 7x plus 4 plus 3. So then your dividend will be divisor 4 into 5 into 7x plus 4 plus 3 plus remainder 2. So this becomes my answer. We have just gone reverse. Okay, we have assumed x to be the quotient for the first case. We wanted red here. I'm not getting. Okay, let me use another color. So let me use blue for once. Okay, so I assume, so this x I assumed, from this I got this as the dividend, which I took as the quotient for this case. Then I got the dividend again, which I have again put as the quotient, and then. So finally what I have got is 4 into 5 into 7x plus 4 plus 3 plus 2. Okay, if I open this, 35x plus 20 plus 3 into 4 plus 2, or it is 140x plus 20 plus 3 is 23, 23 into 4 is 92, 92 plus 2 is 94. This is my answer. Okay, 140x plus 94. And again, it will not give you one answer, but it will give you multiple answers. And the question says, find the largest 3-digit number. So x obviously I can put as 7 or 8. How much? If I put x as 7, in fact you can't put as 7 also. X if I put as 6, you'll get 600 plus 240. 600, 700, 840 plus 94, which will give us 934. So that is the largest possible 3-digit number. Okay, and just to check, here x can be remembered 0 also. X is the last quotient, and we don't know what is the last quotient, but it can be 0 also. So if I assume x to be 0, then the number is 94. Now check 94. 94 if I divide by 4, how many times will it get divided? 2 will be the remainder, 92 will get divided, 92 will be 23 times. So your quotient will be 23. 23 will become the dividend for the next one. 23 divided by 5 will give 3 as the remainder and 4 as the quotient. 4 divided by 7 will give you 4 as the remainder and 0 as the quotient. So you can see that the answer is correct. Okay. Now, you don't have to do this through this long method. I'll tell you a very short method to do this. Okay. So now focus on this part. Your divisors are 4, 5, 7, and your remainders are 2, 3 and 4. Okay, write them like this. And now what you have to do is basically you start from the bottom, remainder, multiply this. 5 into 4. How much do you get? 20. Add this. How much do you get? 20 plus 3. So you are multiplying the diagonal, you are adding the vertical. So 4 into 5 is 20, 20 plus 3 is 23. Again multiply the diagonal. 23 into 4 is 92 and 92 plus 2 is 94. That's how you get 94. If you remember the answer that we had got was 140x plus 94. So we have got this 94, and this 94 is what is the tricky part. Okay, so this 7 does not come in the picture. This 7 has no role. You start with the last remainder, multiply the diagonal. So you're moving from out to in. So 4 into 5 is 20, 20 plus 3 is 23, 23 into 4 is 92, 92 plus 2 is 94. You get this. And the first part is nothing but product of the divisors into a constant. Remember, it is product, it is not LCM. Don't make that mistake. It is not LCM, it is product. So 4 into 5 is 20, 20 into 7 is 140. So 140k plus 94. That's how you get your answer for a successive division question. Okay, and this k is your last quotient. So if it says that the last quotient is 0 or there is nothing left after last division, you can assume k to be 0. Otherwise, depending on the question, we can find out the answer accordingly. Okay, so this is successive division, not related to LCM HCF, but it looks so similar that it made sense to take it together. Okay, so this brings us to the end of the second class. We have in detail understood LCM, HCF, related concepts, and also successive division. So please go through all the theory that we have touched upon today, do all the questions and solve some more questions so that you are absolutely clear with them. And then we will, in the next class, we are going to take up factors and all factors related concepts. Very, very important concepts, very important class. So see you there. Thank you so much. Take care. Bye-bye.